So I'm sharing my screen now. Is my screen visible to all? Can anyone please confirm?
Madam, not visible.
Not yet. Okay.
Yes. Now it is visible.
Visible.
Okay. Okay. So before starting the assignment questions, I'm going to discuss some questions which are raised in previous session. So in the last session, I was some of the student asked me to explain the concept of DHCP, Slack, and service oriented architecture of IoT. So first of all, I'm going to explain the working of DHCP. As DHCP is a protocol which is used in computer networks in order to assign IP addresses automatically. So the working of DHCP is basically in, for example, here consider a client. This is a DHCP client. This want IP address. So first of all, it will send a DHCP discovery message to the server, which is a DHCP server. So this DHCP discovery message is a broadcast message. So DHCP client send this broadcast the message, that is DHCP discovery message. After that, uh, the DHCP server will reply with the proposed IP address. But in the network, there may be more than one DHCP server present. So basically, this DHCP client has to select a particular DHCP server with the proposed IP address, and once DHCP client accept that particular DHCP server, it will again send DHCP request to that particular DHCP server. And after that, this particular DHCP server reply back to the DHCP client with the acknowledgement message. And in this way, this DHCP client will get this IP which is proposed by that particular DHCP server. After that, working of Slack. Slack is another protocol which is again used to assign IP addresses. Uh, but in case of Slack, the working is a bit different. So in case of Slack, there are various steps involved in order to assign the IP addresses to the host. So first step is the configuration of the link local address. So what does this configuration of link local address means? So basically, each system which are present in the network have their MAC addresses. So in this configuration of link local address, what we do is we have to add 8 bits in between the MAC address of that particular system. For example, consider this is the MAC address of the system. Now we have to add these 8 bits. These 8 bits are predefined. We only have to insert FF and FE in between this MAC address. So the center of the MAC address is after this 12. So we will add these 8 bits in between. After 12 we have added FF and FE. Once this is done, then we select the 8th bit of this complete address, and we have to toggle that bit. Toggles means if that bit is 0, then we have to convert that bit into 1. For example, so 8th bit, so the 7th bit here will be this 0. So we have to change this 0 to 1. Now once we change this bit to 1, it becomes 72. Now the address become 72 07 12 FF FE 34 56 78, right? After this has been done, we have to do we again have to do padding. We have to add FE80 into the this complete address. So basically the final address which we got is this one. Now we have to check whether this address is unique or not. So for that we have to do duplicate address detection. In order to perform this duplicate address detection, that particular system needs to join a multicast group. Multicast group here means a particular network. So which network that system is going to join, this is decided by the address which we got here. So basically we have to check the last 6 digits of the address and compare the address of various networks which are present, and that particular system will join the network which have same last 6 digits. uh, After that, once the system join that particular network, then that system will send a ICMP message to all the routers present in that system with the IP address, with the destination IP address of this thing. This is the IP address. So if the router, if some router in the network have same destination IP address, then it means the address is already available in the network. Then that address cannot be assigned to that particular system. But if that address is not, but if any router is not present with that particular IP address, then we consider that this can be a address which can be assigned to that particular system. After that, uh, we have to send a router solicitation message. Here the purpose, this I have already explained to you. Here the purpose is to check whether any of the router have same IP address or not. So a router solicitation message is just a ICMP message which a system sends to various router in that particular unicast network, and if that particular router has that address, then it will reply that it has. Otherwise that particular address can be considered as one of the possible IP address that can be assigned to the system. Now after that, the next step is the configuration of global unicast address. Now we have to combine the prefix this with the EUI64 interface ID. This EUI64 interface ID is the address which we have got in the previous step. So we have to combine both these things together, and at last we will get the global unicast address. And again we have to perform duplicate address detection as we have done in the previous step, to check whether this address is unique or not, and if this address is unique, then that particular address is assigned to the system. Now next is service oriented architecture of IoT. As in computer networks we have studied various models such as OSI model, TCP IP models, which consist of various layers. Similarly here in case of service oriented architecture of IoT, we have 4 layers which are responsible for different functions. So the layers are sensing layer, network layer, service layer, interface layer. So first of all, sensing layer. So this sensing layer is responsible for the sensing of data, for the collection and acquisition of data which we got from various sensors, RFID readers and various devices. Further, the next one is the network layer. This network layer is responsible for the communication of devices, for the exchange of this collected data between the devices. So here we use various protocols. We make use of internet, wireless sensor networks for the exchange of this data which we have collected in the sensing layer. Now the third one is the service layer. This service layer is responsible for providing services for providing various services. So basically here we have a service repository which consists of various kinds of services that are available. The services can be anything. For example, it can be monitoring. We can consider an example in case of industrial monitoring processes. The service can be monitoring the health of the machine or anything. These services can be anything. So this layer is responsible for providing those services to the end user. And here this service bus is responsible for interconnecting different services to the application layer. Now the last one, that is interface layer, or we can also call it as application layer. This is responsible for providing interface to the end user. So this layer basically consists of application front end through which the end user can communicate with your system. Interface is same thing, application, API and contract. So if you want more details about the service oriented architecture of IoT, I have given the link for the research paper from where this architecture has been taken. So you can
Hello.
hello, yeah.
Madam, can you brief it once more?
Yeah, okay, okay. So basically, the service-oriented architecture of IoT consists of four layers. First one is the sensing layer, right? Sensing layer is responsible for the acquisition of data, for the collection of data. So basically, in sensing layer, various sensors are going to sense the environment and collect data. Now the second layer is the network layer. This network layer is responsible for the communication of various devices which are present in the sensing layer. So basically in the network layer, the exchange of data with the help of various protocols or with the help of internet can take place. Next one is your service layer.
So the service providers come in this layer, isn't it?
A service provider come in your service layer. In case of your network layer, just various protocol which are responsible for the communication of various devices comes.
Okay, okay.
Yeah. And last one is your interface layer, that is responsible for providing interface. You can compare this architecture with your OSI model in computer networks. For example, in your OSI model, there is application layer, right? So that application layer is responsible for providing various protocols that are responsible for interfacing with user. Similarly, here also there are various protocols used in this interface layer which are providing interface or front end to the end user, so that the end user can communicate with other devices. Further, yeah, service layer is not present in your OSI model, so here it is different. So all the service providers and how the service can be provided to the user comes under this layer. Third one is network layer. This is similar to your OSI model, that this layer is responsible for the communication of various devices. And last one is sensing layer. This one is responsible for the collection of data from the sensors. And you can also refer to this paper, link is already given here. So from this paper only we have taken this architecture. Yeah. Before going to question number one, last week someone has asked me the question that in sir's lecture, sir has mentioned that IPv6 is not um, only the protocol which is used by IoT devices. That IPv6 is not enough for IoT devices. This is because in case of IoT devices, apart from your this communication that take place with the help of routers, different kind of other communication, that is your direct communication with the help of cables, either P2P communication, different kind of communications take place. So that is why only IPv6 is not enough for your IoT devices. We use IPv6 in your IoT devices, but apart from IPv6 there are other protocols also which are required for the communication in IoT devices. Now the next question, that is the question number 1 of week 2 assignment is which of the following is not a data and communication protocol? Options are MQTT, second one is AMQP, third is WebSocket, and fourth is AllJoin. So before answering this question, we have to know that what are the different protocols that are used in IoT. So basically, there are we have categorized the IoT protocols on the basis of their functionality, and these can be on the basis of the connectivity which they are providing. Identification protocol can be there, communication and transport protocol can be there, discovery protocol can be there, data protocols can be there, device management protocols can be there, semantic protocols and multi-layer framework protocols can be there. So what those different kind of protocols means? First of all, your connectivity protocol. This connectivity protocol, the connectivity protocols are those protocols which are responsible for establishing the connection between different devices which are present in the IoT network. So basically, this connectivity protocol are responsible for establishing, for making the two devices to interact with each other. So, the example of this connectivity protocol can be LoWPAN and RPL. The next one is your identification protocol. So this identification protocols check the identity of the user in your network. Consider an example that we have a network where any device cannot participate. We need only certain devices which can participate in that network. So to ensure the privacy, we need we need to allocate identity to each of the devices which are there, and in order to check their identity we need some protocols, right? So this identification protocols are responsible for providing this thing, and this identification can be provided with the help of your password, private keys, those things. The examples are EPC, UCode, IPv6 and URLs. After that, next one is your communication and transport protocol. This communication protocol is responsible for making two devices to communicate with each other. See, first one is your connectivity protocol. Connectivity protocol is just making connection between two devices. However, your communication protocol is responsible for exchanging data between two devices. So example of this communication protocol is Wi-Fi, Bluetooth, LPWAN. Next one is discovery protocol. This discovery protocol is responsible for the advertisement as well as the discovery of various network services which are available. So network services can be DNS, as you have already learned in computer networks that DNS is used to provide domain names. As it is difficult to learn IP addresses, right? So we need some names for the particular IP addresses. So in that case, DNS server are there, and which provide domain names to your IP addresses. So such kind of services comes under your discovery protocols. Next one is your data protocol. The data protocol is responsible for the exchange of information. Now again, what is the difference between your communication protocol and your data protocol? Both are responsible for the exchange of information. See, this communication protocol is responsible for communicating between two devices. However, your data protocol will tell that how your data will transfer from one device to another device. Next one is your device management protocol. Device management protocol is responsible for managing your different devices that are present in your IoT network. Next one is semantic protocol. This one is responsible for regulating application related aspects of your communication. Next one is your multi-layer frameworks. So these protocols does not lie in particular layer. They may lie in different layers. So example you can read here. LJoin, IOTVT, Wave, HomeKit are the example of multi-layer frameworks. From here we can see that this AllJoin is not a data protocol, it is a multi-layer framework protocol. So the answer for your first question is AllJoin. All your MQTT, AMQP WebSockets are your data protocol and your communication protocol. You can check over here. This is your communication protocol and this is your data protocol. Next question is, which of the following AMQP frame type is used to inform the changes in state of transfer? Options are flow, disposition, transfer, state. So in order to answer this question, we have to know that what are the different frame types that are used. So these are the various frame types which are used by this advanced message queuing protocol. First one is your open frame. Second one, this open frame is responsible in order to open the connection between two devices. The next one is your begin. Begin is responsible for the opening of session. See, in a particular connection, there can be more than one session. So this open is responsible for opening the connection, and this begin is responsible for opening a particular session in that connection. Then third one is attach. If you want to attach some new link with that particular connection, then you will use this attach frame. Next one is transfer. Transfer is responsible for the transfer of actual messages through that link. Next one is flow. Flow frame is responsible for the transfer of your control messages. Transfer is responsible for the normal data messages and flow is responsible for the control messages. Next one is your disposition. Disposition is responsible for informing the changes that happen in during the transmission of your data. So next one is your detach. Detach is to terminate the link. Then your end is responsible for closing the session, and close is responsible for closing your connection. So the right option for your question is disposition, as disposition is responsible for informing the changes that occurs during the state of transfer. Yeah. Next question is, which of the following is not a messaging mode of CoAP? Options are separate, pager, piggyback, confirmable. So anyone would like to answer this question? No?
Pager.
Okay. Yeah. So basically your CoAP has four types of messages. These are confirmable, non-confirmable, piggyback and separate. Your pager is not included in this CoAP. Now we will see that how these different messages take place. So in case of your confirmable, the there are there are client and a server. The connection established between your client and server. In case of your confirmable message, once the connection is established, you will get an acknowledgement from your server. However, in case of your non-confirmable messages, you will not get any acknowledgement from your server. So this is the basic difference between your confirmable and non-confirmable. Next one is your piggyback. Piggyback is just ki you are sending your data with your acknowledgement. You are not using any separate frame in order to send your acknowledgement. So in the same frame you are sending your acknowledgement and data together. However, in case of your separate, you are not sending data and acknowledgement together. Initially connection is established, then the server will acknowledge with your acknowledgement message, then it will wait for some time, and after that it will send your data. And once your client will receive your data, it will again send acknowledgement to the server to inform it that it has received the data successfully. So yeah, correct option is your pager. The ZigBee component API stand for. Option A is application support sublayer. Option B is application protocol support. Option C is application policy support. Option D is application protocol sublayer. Uh, Anyone, please? It's just a abbreviation.
Option B, application protocol support.
Application application protocol support. Anyone else?
Option A.
Yeah, option A. ZigBee has basically two components, and one of them is your APS, where APS stand for your application support sublayer, which is responsible for providing interfaces and your control services. It also acts as a bridge between your network layer and your other layers. So your APS stands for application support sublayer, not application protocol support. Next question is, does IEEE 802.15.4 support IPv6 multicast? Before that, can anyone tell me that for what this IEEE 802.15.4 is used to? Anyone?
For connecting upper layers of the
No. I'm just asking that this IEEE 802.15.4 is a standard, right? So this standard is representing what? For example, your Wi-Fi is represented, if I'm not wrong, 802.11. Similarly, this IEEE 802.15.4 is representing what? Anyone?
Ma'am, standard specification for communication.
Exactly for what?
Between the devices.
Which kind of devices?
Connecting devices.
So connecting devices can be any of type, right? So basically this your IEEE 802.15.4 represent low rate wireless personal area networks. Okay. So does this support IPv6 multicast or not? Anyone, please?
yes supports madam.
It supports.
Not supports. Not supports me.
Okay. Yeah, it does not support IPv6 multicast. This is because see this your IEEE 802.15.4 support broadcasting. However, in case of your IPv6, broadcast is not available. Only multicast is available. That's why it does not use your IPv6 and it does not use your IPv6 multicast. Next one is, in MQTT, a blank subscribes to a topic. Options are client, broker, publisher, all of the above. Anyone, please?
All of the above.
All of the above.
A.
A. How all of the above
Option
can be
A.
answered? See, your publisher is publishing your services, not it subscribes to that, right? See, in case of your MQTT, it follows your publish subscribe based model. In case of your publish subscribe model, there are basically three components, that is your publisher, broker, and subscriber. Please mute yourself. Yeah. So your subscriber are also called as client. So basically, in case of your publish subscribe model, your publisher is going to publish the services to the broker, and further from the broker, various clients are going to subscribe those services, various kind of services they need. and according to their subscription, this broker is going to publish the services to the subscriber, or you can also call subscriber as client. Please mute yourself. So answer, the correct answer for this is a client. So client is going to subscribe a particular service from the broker, and your publisher is going to publish the services to the broker, which further will give a subscription to your client. Now the question is, which of the following is a characteristic of XMPP protocol? Options are no interoperability, second one is closed standards, third one is no central server, and fourth one is all of the above. So can anyone please tell me what are the various characteristics
No
of...
central server.
Okay, fine, but can you please tell me
No
what
central
are...
server, ma'am.
Yeah, right, no central server. Can you also tell me various characteristics of XMPP? That what are the other characteristics of XMPP?
It can be used for cloud computing and virtual machines, firewalls.
Okay. Anyone else? It is covered in lectures, right? Anyone? No? Okay. So your XMPP first of all stands for Extensible Messaging and Presence Protocol. It is a communication protocol which is used for your message oriented middleware based XML. XML is extensible markup language. So basically in your XMPP, your structured data is transferred or get exchanged in real time. In case of your XMPP, there is no central server. There are various servers which are used. So it follows decentralized architecture. After that, it is an open standard protocol, which offers security, and last one is it also offers interoperability. The next question is, which of the following is a characteristics? Yeah, this is the same question, and the option the correct option is no central server. Question number 8 is, which of the following has a component named bindings? Options are your XMPP, AMQP, third one is CoAP, and fourth one is none of the above. So to answer this question, you have to know the components of these three protocols. So can anyone please tell me what is the correct option? Anyone? Okay. So the correct option for this is AMQP, as there are three main components of your AMQP, that is your exchange, queue, and binding. First is your exchange, which is responsible for routing the messages to your queue. Queue is responsible for storing your messages, and it provides, and see, there will be different queues for different processes, different business processes. So the data of different business processes get stored in different queues, and after that, bindings are the rules which are used to distribute these messages to the end users. Yeah, so option is right option is AMQP. Next one is CoAP is restful or not? Anyone?
Yes.
Okay, can you please tell me that what do you mean by restful? Anyone?
Anytime the state of the web application will be saved.
Anytime the state of the web application can be saved, right? Or anyone else?
So the answer for this question is yes.
Yeah, answer for this is yes. I just want to know more about RESTful. One, you tell the state is saved. Other things.
For example, it helps like users HTTP to access to interface
What?
between services like
Repeat, please.
get, post, or
Yeah, right. It use the various functions that are used in HTTP, that get, post, all those things. So the answer for this is yes.
That is, we have to make a request, and once if your request gets accepted, then only you can able to access the data.
Yeah, right. Now the last question is, RPL routing is based on blank routing protocol. Options are enhanced interior gateway, second one is interior gateway, third one is open shortest path first, and fourth one is your distance vector IPv6. Anyone?
D option.
Which option? Louder please.
D. D.
Option D.
Option D, that is your distance vector.
Distance vector
Can you please
IPv6?
tell me what is distance vector?
Ma'am, it stores the distance between the different routers at location in an array of each nodes.
Can you please tell me the difference between? Achha, do you know about link state
And
protocols?
the best path will be selected based on the minimal cost.
Okay, and what in case of link state protocol? What is the basic difference between your link state protocol and distance vector protocol?
It is in distance vector protocol, ma'am. It uses a vector which is an array of all the distance from a given nodes. But in linked state, we are using a minimum distance, optimum distance from a node to a destination node.
Anyone else? Okay, just a hint. In
I
one
think
case,
distance vector will just take.
Yeah, please.
Yeah, distance vector finds out whichever the minimum distance that it can able to reach the destination, right?
Okay, and what about your link state?
Link state just find a path which can reach the destination, but distance vector will find out the destination which can be reached by a minimal cost.
Okay, acha, okay. I'll give you hint. You have to tell me that the statement is related to distance vector or your link state. So, uh, in first protocol, okay,
Right.
yeah, the information or knowledge of your complete network is required. This is true in which case, your link state or distance vector? In one protocol you need to have
Distance vector.
distance vector, and
Distance
in case
vector.
of your link state you don't require the complete information of your network.
Yeah, in distance vector you require the complete information.
And in case of your link state,
Only neighbors are
Link
required.
state it's not required that it.
yeah, in case of your link state, complete information, the information about your complete network is not required. Just the router will need the information of its neighbor nodes only. However, in case of your distance vector, you need to have complete information. Okay. So okay, other question you want to ask related to this assignment, or you want me to discuss in next session, or any topic which you want me to discuss in next session?
Ma'am, I just want to ask a question. Is the questions what you are discussing,
Yeah.
is it related to this assignment or?
No. This is not related to this assignment. These are the questions which were asked in the previous run of this course.
Okay,
Did
okay,
you?
fine.
Yeah. So these type of question can be asked in your exam. So this is just a practice session. So that.
So I just got confused because the questions what I have answered is different.
No. These are different questions. These are the
Sorry.
questions, which were asked in the previous run of this course. So this is just a session so that you can have a flavor that which kind of questions can be asked in your exam, or uh, this is just a problem solving session. So okay. So any topic which you want me to discuss in the
Sure.
next session?
Ma'am, yes, ma'am.
Which?
Actually, I have a doubt regarding
Ma'am, WebSocket, ma'am,
MQTT
data
broker. So
protocols.
what MQTT broker?
One by one, please. One of you told ki WebSocket you want that how WebSockets work, right?
Yes, ma'am.
Okay.
Yes, ma'am.
So, do you know about client server programming? Just a question.
Yes, ma'am, little bit. Yes, ma'am.
Little
I
bit.
have implemented
Okay, which kind of
some of the programs.
programs you have implemented?
Ma'am, just like transferring data from one device to another device.
Okay, using UDP, TCP, which protocol and what? Can you please give?
Yes, ma'am.
Yeah.
UDP and TCP
Both.
and both. Yes, ma'am.
Okay. So what exactly in
Ma'am, I want to
WebSockets?
know more about it because,
Okay.
ma'am, WebSocket is a way of transferring the data between client and server
Yeah.
using a protocols like TCP or UDP. You can choose any one of them.
Hmm. So what exactly you want me to discuss?
Yes, ma'am.
Because WebSocket is a complete different topic and
Ma'am,
it
how this
requires
is used in
time.
IoT?
How it is used in IoT? Okay.
Ma'am, how we can transfer from one client to multiple servers?
Transfer from one to multiple. Okay. Anything
Or
else?
vice versa, ma'am.
Yeah.
Ma'am, I had a doubt about the MQTT broker. Is
Huh.
it some kind of a cloud service or a server that
Can you
helps? For
please
example,
repeat? Can you
if
repeat,
I have
please?
a
Can you please repeat?
what?
I didn't get what you said.
Yeah, no. My question was about the MQTT broker. Like, is
MQTT.
it some kind of server? For,
No, it is not a
yeah, if
server.
I'm
It's just a protocol similar to your TCP protocol, your IP protocol, which is responsible for exchange of data. See, your TCP is responsible for exchange of data. However, your MQTT protocol is a data protocol which is responsible for that how your data will transfer. It is not a server. It will tell you, it is a way that will tell you that how you are going to transfer your data.
but what is the broker? The broker, the component.
Yeah, so these are the various components which are used in your protocol. Broker is your something you can consider it as a device. Broker is a device, however your MQTT is a protocol which use these different components, right? So, this your subscriber is a device, your publisher is a device, your broker is a device which is going to use your MQTT protocol. Fine. Anything else? Yeah, Yeah, someone has written that can you please share the PPT? See, these PPTs are I think already posted by NPTEL team on the web page of this course, I guess. Are you not getting these things?
No, we are not getting these PPTs.
Okay, okay.
And one more thing of concern,
Yeah.
the V2 material, what the lecture material, what has been posted, it is not in the sequence of the lecture. Actually, it's jumbled.
See, these things actually I'm not going to handle. You can put this thing in your discussion forum, right? So there is a discussion forum. You can post these things in that. Okay. Any other thing that you want me to discuss in next lecture? Any topic which you want me to discuss? I want to know the questions with answer from 1 to 5. Which questions and which answers? Can you please tell me?
Is it possible that you can specify this data protocols
Okay.
in an application perspective, in where it is used, how it can be done? So a lot of protocols is discussed, right? So in which of the applications, what type of protocols might be helpful? So if some idea is given on that context, it will be helpful while building an application.
Okay, okay, fine. In the next session, I'll tell you that in which kind of application, which protocol
In the
is
data
suitable.
protocols, as well, because at least for the communication protocols we have an idea, but for the data protocols we doesn't know when it should be used and where it should be used.
Okay, okay, I'll check and let you know. So we have 9 more minutes. If you want to discuss anything, or if you want me to discuss anything in the next session, you can share. Otherwise, I'll conclude this session.
Ma'am, I just want to know the basic difference between the bridge and the gateway.
Bridge and gateway. So, are you from CSE background?
Yes, yes, I'm from CSE.
Okay. So basically, do you know what exactly is gateway? Definition, do you know?
As per my understanding, is that as per my understanding, I feel that when you want to communicate across two different
Your voice is breaking. Can you please write?
to commute LAN network, I think bridge will work.
Your voice was not clear. Can you please write down in chat box?
Yeah.
I just want to know whether the definition you are giving is correct or not. After that, I'll give you the difference, that what is the basic difference between bridge and gateway. Can you please share the questions from 1 to 5 with answers? Questions of this session, or you are talking about the assignment which you got this week? PPT. Yeah, this PPT will be available to you. NPTEL team will share this PPT with you. before you write, I'll tell you the difference between your gateway and bridge. So both these devices, your bridge and gateway, both are used to connect your different networks together. So your bridge is going to connect two networks which are using same protocols basically. So your networks will be homogeneous. However, your gateway, in case of your gateway, a gateway is going to interconnect your two heterogeneous networks together. So the protocols which are used by these two networks can be same or can be different. However, your bridge is only going to interconnect the networks which have which are using same protocols. Hello. Do you want me to? Do you want any other question? What are actually frames? In Sir PPT, it was told it was some data. Yeah, actually, see, if you have studied computer networks, then we are using different words for data in different layers. So frame is basically a word which is used to represent data in your data link layer. So frames are just your data plus some header in that data. So you can use various terms like
I
packets.
just, suppose say for example, I want to communicate.
Your voice is not coming.
I